Alright, in this video we're going to talk about Unit 2 Objective 5 trig rules. So whenever we take derivatives of trig functions, we're almost always going to have to use the chain rule. Now, we're going to try to make this to where you don't have to think about using the chain rule, so we're going to define our trig rules in terms of the chain rule. So for all of these rules down here, we're going to let this u be some function of x. So u could be something like x squared or 3x plus 4. Something in terms of x, or u could just be x. So the derivative of sine with respect to x is going to be u prime cosine of u. So the derivative of the cosine, or I'm sorry, of sine is going to be cosine. But remember, we have to use chain rule, so we can kind of think about there being parentheses around the u, so we can think of it as like sine of u. So the derivative of the outside piece is going to be sine. That's the outside piece. So the derivative is cosine. Keep the inside the same, and then multiply by the derivative of the inside, so u prime. So really the derivative of sine is cosine, but the derivative of sine of u is going to be u prime cosine u. The derivative of tangent of u, so again we're going to have that u prime, because that's going to be the derivative of the inside part, times secant squared of u. The derivative of secant u is going to be u prime secant u tangent u. So again, chain rule is where all of these u primes come from. If you have just sine of x, your derivative is going to be just cosine of x, because the derivative of x is 1, so this u prime would be 1. Moving on to our co-functions. So these are co-functions because they start with cosine, cotangent, cosecant. The derivative of cosine of u is going to be negative u prime sine of u. Cotangent is going to be negative u prime cosecant squared of u. And cosecant is going to be negative u prime cosecant u cotangent u. So you should notice something here. All of our co-functions, when we take the derivative, are negative. And if you know your functions over here, your co-functions kind of match, right? Secant squared, cosecant squared. Secant tangent, cosecant cotangent. So if you know this left side, you should know this right side pretty well, because it's just the equivalent co-function and everything's going to be negative. So let's look at a couple of problems here. Actually, before we look at a couple of problems, let's look at this little thing here. This is just an easy way to remember positives and negatives with sines and cosines. So if we think about our unit circle, the point 0, 1, if we think about where the 1 is, the 1's with our sine. Over here, our 1 would be cosine, right, because sine is 0. If we go down here at negative 1, we really have negative sine of x, right, because we're in the negative. And on this side, we're going to get negative cosine of x. So when we're taking derivatives, if you think about this as like a clock face, as you go clockwise, you're going to be taking derivatives. So if you have the function negative cosine of x and you want to take its derivative is going to be sine of x. Later on, when we start talking about antiderivatives, we're going to revisit this little thing and it's going to work the opposite way. But for now, we're just going to go clockwise with our derivative. So derivative of sine is cosine, derivative of cosine is negative sine, derivative of negative sine is negative cosine, derivative of negative cosine is sine. So that's a neat little way to remember with your positives and negatives, because those can get a little cumbersome. So let's look at a couple of examples. First one, find dy dx if y equals sine of x squared plus x. So if we're looking at this, we can think of that u as x squared plus x. So we know that the derivative, if y equals sine of u, we know that y prime is u prime cosine of u. So if this is our u, if this is the inside, we know that u prime is 2x plus 1. So the derivative, dy dx, of sine of x squared plus x is going to be the derivative of x squared plus x, 2x plus 1, times the derivative of sine, which is cosine, of u. So this is going to stay x squared plus x, because remember it's chain rule. So we took the derivative of sine to get cosine, kept the inside the same, and then multiplied by the derivative of the inside, 2x plus 1. But if we just learn our rules as far as u prime cosine u, that's going to help us with that chain rule, and we're not going to really have to think about it. So let's look at one more. Let's look at find dy dx if y equals tangent of 5 minus sine of 2x. So in this case, u is equal to 5 minus sine of 2t. So if we're going to try to find the derivative of that, the derivative of 5 is 0. If we think about that little wheel we had, the derivative of negative sine is going to be negative cosine, but we have this 2t, so really we're going to have to think about a second u. So we can think about this red u as 2t, right? Because if we think about just sine, we have this u again, so the red u prime is just going to be 2. So negative sine's derivative is negative cosine, so we have that 2 here, so negative 2 cosine of 2t. So that's the big function's u prime. So we can multiply this by the derivative of tangent, so we can say dy dx is equal to negative 2 cosine of 2t times, and the derivative of tangent was secant squared. So secant squared of, keep the inside the same, 5 minus sine of 2t. So what we really had going on here is we had chain rule within chain rule. So we had chain rule with the tangent, and all of this stuff was the inside function. But inside, we had another chain rule, so we had a second inside with this 2t. So sometimes we're going to have chain rule within chain rule, and we're going to have to take that into account. So the easiest way is to just break it down piece by piece. The inside, we know we're eventually going to have to take the derivative of, so we think about that as its own problem. With that as its own problem, sine of 2t has a trig function, right? So we have to think about that as u prime cosine t. So we had to take the derivative of that u again, that 2t, so that's where this 2 came from. So, big picture for trig rules is you just have to memorize your trig rules. If you take it step by step, they shouldn't be too bad once you put them all to memory. So we'll call it quits on this video. We'll see you in the next one.